Now we want to show that these are solutions of these differential equations. So again, I've chosen two examples. The first one is y prime plus y equals sine of x. And the solution is y equals 1/2 sine of x minus 1/2 cosine of x plus 10 times e to the minus x. So what I want to do is I want to take this y and plug it into this differential equation. So the first thing I've got to do is I've got to take the derivative. So I only have to take one derivative, so y prime equals the derivative of sine of x is cosine of x, so this would be 1/2 cosine of x. The derivative of cosine of x, of course, is negative sine of x, so a negative times a negative is a positive. So this would be plus 1/2 sine of x. The derivative of e to the minus x is negative e to the minus x, so this would be minus 10 e to the minus x. Now what I want to do is I want to take these two and plug them up here and see, do I get sine of x? So y prime would be 1/2 cosine x plus 1/2 sine x minus 10 e to the negative x. Now I'm going to add y here. So I'm going to take this and add 1/2 sine of x minus 1/2 cosine of x plus 10 times e to the negative x. Let's see what we get. Well, what do I notice? I got a 1/2 cosine x and a negative 1/2 cosine of x, so they cancel out. I have a 1/2 sine of x plus a 1/2 sine of x. That's a sine of x. I have a negative 10 e to the negative x plus a positive 10 e to the negative x. Of course, those cancel out. So look what I get. I get sine of x, sine of x. So we have just proven that this is a solution to this differential equation. For my next example, I've got y double prime equals y. I'm claiming that y equal to hyperbolic cosine of x plus hyperbolic sine of x is a solution to this differential equation. For those who don't remember, hyperbolic cosine of x is e to the x plus e to the minus x over 2. Hyperbolic sine of x is e to the x minus e to the minus x over 2. And then you have all the 6 hyperbolic functions. When it comes to derivatives, the thing I always remember about the hyperbolics is that the big three, that is the hyperbolic sine, the hyperbolic cosine, and the hyperbolic tangent, their derivatives are all positive. Whereas the lesser three, the hyperbolic secant, the hyperbolic cosecant, and the hyperbolic cotangent, all have a negative in front of them, as opposed to the trig functions, the 6 trig functions. The trig functions, if you haven't noticed, the 3 co-trig functions, their derivatives are negative, whereas the other 3 trig functions are positive with their derivatives. And by the way, the hyperbolics, the derivatives imitate exactly, except for that plus or minus, what the derivatives of the trig functions are. So having that as a background, let's take a derivative. Now, I don't need the first derivative in the equation, but I've got to find the first derivative to find the second derivative. So the derivative of hyperbolic cosine of x would be hyperbolic sine of x plus hyperbolic cosine of x. Notice it didn't change, really. So that tells me what the second derivative is going to be also. It's going to be the hyperbolic cosine of x plus the hyperbolic sine of x. Well, look at these two. They're equal. So this satisfied the differential equation. Therefore, this y equals hyperbolic cosine of x plus hyperbolic sine of x is a solution to this differential equation. So again, like I say in class, this is a solution because it makes sense in the differential equation. It makes the differential equation true. If you can plug it in and it makes it true, then it is a solution.